right, so just like before, we have our 2/3, 5/6. So that means our x will equal 2/3, and our y equals 5/6. Okay, so we'll go ahead and plug it into our first one, see what happens. And I'll just separate that here. So we have negative 8x minus 10y equals 3. Okay, so we plug in our x. That's negative 8 times 2 over times 2 over 3 minus 10 times 5/6 equals 3. Okay. So that 8, if we wanted to, we could rewrite it as 8/1. So that's negative 8/1 times 2 over 3. Same thing with 10. We can make that 10/1 minus 10/1 times 5/6 equals 3. Okay. So with multiplication, you just have to multiply your numerators and your denominators. So negative 8 times 2 is negative 16 over 3. Negative 10, well, you just might minus 10. So minus 10 times 5 is 50 over 1 times 6, which is 6, is equal to 3. Okay, so now we're just subtracting two fractions, which you can't really do as long as your denominators are different. So you have 16 over 3 here. So negative 16 over 3 minus 50 over 6. If you multiply 3 times 2, you'll get 6. So we'll just multiply that by 2. And anything you do to the denominator, you have to do it to the numerator. So we multiply that by 2 over 2. And move that up a little bit. Okay, so 2 times negative 16 is negative 32. 2 times 3 is 6. Minus 50 over 6 equals 3. Bring that down a little bit more. Okay, so since you have the same denominator, we can go ahead and combine those two. Okay, so we have negative 32 minus 50 over 6 equals 3. Okay, so negative 32, oh, where is it? You can make that plus negative 50 if you wanted to. Oh, where is it? Okay, so that, let me move this up a little bit. That should give us negative 82 over 6. I'm missing a negative somewhere because that actually should have worked out. That's why it didn't work out. This should have been negative 5 over 6. Sorry about that. Actually, this should have worked out to be true. Okay, so if we make that negative 5 over 6, and just make everything else negative. Because when we got to that point, we have the minus negative, that would have made that positive. Okay, so everything else just kind of goes from there. So going up a little bit more, you have negative 32 plus 50 ends up being positive 18. So 18 divided by 6 is 3, so we end up with 3 equals 3, which is true. Okay, so we're good for the first one. Now we just have to double check the second. Yes?
Could you have simplified 50 and 6 to 25 over 3 and then just subtracted from that instead of doing all that extra?
Yeah, you could have. What's the fun in that? Okay, so now we try the second one. So we have 6x minus 6y equals 0. So if we plug in 6 times 2 over 3 minus 6 times negative 5 over 6 equals 0. Okay. Now with this one, you could have simplified it by canceling out, or you can just multiply it across. Up to you. Okay, so if you made that 6 over 1 times 2 over 3 minus 6 over 1 times negative 5 over 6 equals 0. 3 goes into 3 one time. 3 goes into 6 twice. These two 6's will cancel each other out. Okay, so you have 2 times 2 over 1, so you have 4 over 1, which is just 4. You have minus 1 times negative 5, which is negative 5 over 1. And, yeah. Actually, that should be, yep, plus 5 equals 0. 2/3 minus negative 5 over 6. Okay, so you end up with 9 equals 0, which in this case is false. Okay, so after all that work, it's not a solution. All right, any questions on that one?
Why'd you put the 5 in parentheses?
Which one?
Oh, that, yep.
Oh, because when you have the negative 5 here, I was going to put negative 5, but I'm like, nah, might as well just go ahead and make it, since it's minus negative, make it plus.
Okay.
So you didn't have to put the parenthesis, but I already drew it and was too lazy to erase it. Actually, let me go ahead and just make that plus 5. All right, so I'll leave that up. We'll do one more. And then we'll go on to the next part of it. Anyone's still writing? All right. Look like everyone's done writing. Okay, what if we want to determine if 0, negative 3 over 2 is a solution to the system. Okay, so what if we have 10x minus 6y equals 9, and negative x minus 2y equals 3. All right, so just like we did before, we know that our 0 and negative 3 over 2 means that our x will equal 0 and our y will equal negative 3 over 2. Okay. Then we just plug them both in, see which one's true, which one's not. Okay, so if we go for our first one, our little separator there. So we have 10x minus 6y equals 9. Okay. So we'll go ahead and plug in our x and our y. So we have 10 times 0 minus 6 times negative 3 over 2 equals 9. Okay. So if you want to cancel out the 2 and the 6, you can, or you can multiply 6 times negative 3. You can do either one. Okay, 10 times 0 is 0, so that just disappears. So you have negative 6, or you can write it as negative 6 over 1 if you want to, times negative 3 over 2 equals 9. Okay, so if we just go ahead and multiply them together, you have negative 6 times negative 3 is positive 18. Over 1 times 2, which is 2, equals 9. So if we simplify the left side, 18 divided by 2 is 9, so we have 9 equals 9, which is true. We'll bring that up a little. Okay. So one of them is true. Now we just have to work and see if the other one is true. Okay. So this one we have negative x minus 2y equals 3. Okay, so if we go ahead and plug them in, x is equal to 0, so that's just negative 0, minus 2 times negative 3 over 2 equals 3. Okay. Negative 1 times 0 is 0, so that disappears. So these 2's can actually cancel each other out. So you have minus negative, which is plus. So you end up with this 3 equals 3, which is true. Okay. I mean, you have both of them true. That just means that 0 and negative 3 over 2 is a solution. Oh, did I write not a solution? All right, so any questions there? All right, I'll leave that up for a few more seconds. Okay, so all the ones where that point was a particular solution, that just says that if you were to graph both of them, that's the point where they both cross. Okay, so that's how you know if you have one and the other one and they're both crossing, that's the x and y point that they intersect. So now we're going to actually look at solving systems by graphing. Okay, and all that where we know a solution of two lines in a system is the point where they intersect. So every solution we had just told us where they crossed each other. Okay, so let's say, for example, solve the system of equations by graphing. Okay, and let's say if we have the system negative x plus 3y equals 10, and x plus y equals 2. Okay, so the first thing you want to do is you want to create a table for both equations. Okay, create points for both equations and graph. Okay, so that means where you don't have to do the table, but I do it just out of habit. Okay, well, this is your x, and this is your y. This is your x, and this is your y. And a lot of times it's easier just to use the x and y intercepts for your points, only because it's just quicker. Okay, so if we make x equals 0 and y equals 0, x equals 0 and y equals 0. Now this one's for negative x plus 3y equals 10. And this one's for x plus y equals 2. Okay. So if we made x equals 0, we have 0 plus 3y equals 10. Which gives us 3y equals 10. Divide both sides by 3. We have y equals 10 over 3. Okay, so if we have our 10 over 3, remember we can convert that, just making that 10 divided by 3. 3 goes into 10 3 times. 3 times 3 is 9. Subtract, you get 1. So that means we can convert this to y equals 3 and 1/3. Okay, and it doesn't have to be perfect. So we can actually point our 3 and 1/3 and graph that. Okay, so now our x plus y equals 2. When x equals 0, you just have 0 plus y equals 2, so y equals 2. So that one's pretty straightforward. Okay, so we know y is equal to 3 and 1/3 here, and 2 there. Okay, so now solve when y is equal to 0. This one, when y is equal to 0, that means you have negative x plus 3 times 0 equals 10. 3 times 0 is 0, so that disappears. So we have negative x equals 10. Multiply both sides by negative 1. You have x equals negative 10. Okay, so we can put our negative 10 there. For this one, when y is equal to 0, that gives us x plus 0 equals 2, or just x equals 2. Okay, so we can put our 2 right there. Okay, so we know for this one, we have 0 and 3 1/3. And we have the point -10, 0. And for this one, we have 0, 2, and the point 2, 0. So really, that's all we had to do was what we did before, was create a line. And I'll call this example A. So that when we go to the graphing paper, we can just make that example A. I'll leave that up for a few seconds, then we can graph it. Okay. All right, so looking at example A, we know we have the point 0 and 3 1/3. So when x is equal to 0, y is 3 1/3. So 3 1/3 is just a little bit above 3. Like I said, it doesn't have to be perfect. Okay, and we have the point -10, 0. When x is equal to -10, y is equal to 0, so it's right on that point. Okay, so we can use a sheet of paper or something to just connect those two. All right, so that's our graph of -x plus 3y equals 10. Now we graph our other 2 points for our next graph. So we have 0, 2, and we have 2, 0. And again, you can grab a piece of paper or something and connect those two lines. And make sure they're connected. There you go. Okay, so with this one, it looks like it's really close to -1, 3. Now, since it's really close to -1, 3, all you have to do is plug that in and you can verify it. Okay, so that is our -1, 3 point there. So if we go ahead and pull up a sheet just to verify it, I'll leave that showing. Or better yet, I'll just put that up top. Okay, this is just to verify -1, 3 as a solution. Okay, so we did just like we did before, we just plug it right in. Okay. So you have -x plus 3y equals 10. Remember, this is just saying x is equal to -1. Y is equal to 3. Okay, so if we plug in our -1, that's -1 plus 3 times 3 equals 10. No problem. Minus and negatives, that just cancels out to become positive, so that gives us 1 plus 3 times 3 is 9, equals 10. 1 plus 9 is 10, so that gives us 10 equals 10, which is true. Oh, where did I forget the 0? Oh, thank you. We have 10 equals 10, which is true. So now we have to verify it for the other one. So you have x plus y equals 2. So that gives us -1 plus 3 equals 2. -1 plus 3 is 2, so we have 2 equals 2, which is also true. Okay, so we can see there that -1 and 3 is actually your solution, because that's the point where they both cross each other. Okay, so -1, 3 is a solution. All right, does that make sense? Okay. All right. Okay, so let's say if we, I'll do this one. Anyone's still writing? Oh, leave it up for a few more seconds. All right. Okay, so let's say if we wanted to solve the system by graphing. Let's say you have 2x plus 3y equals -2, and x equals 2. So just like before, you just want to graph both of them. The x equals 2, that one's pretty easy because that's just a straight up and down line. But your 2x plus 3y equals -2, and we'll call this example B, just so we'll know what graph it matches up with. You have your x and you have your y. And again, we can use the intercepts. Okay, so this is for 2x plus 3y equals -2. Okay, so when x is equal to 0, we have 2 times 0 plus 3y equals -2.